Lecture 7.1, Publishing to Topics. So we're finally ready. Now that we've got our repository is all set up, we've got our robotics book code all good to go as shown in resources 2 and 3. So now we're going to take a look at publishing topics. New topics must first be registered with Big Other ROS core, which will thereafter advertise this topic to other nodes. So in ROSPy, the syntax is as follows. So rospy.publisher, you give it the topic name string, and then you give it the message type. Okay. The first argument is the name of the topic, and the second is the message type. All messages on a topic have the same type. So we give it the type there, and then thereafter everything on that topic must have that type. This registers the topic name. Later, we will learn to create our own message types, but for now we'll stick to the standard message types defined by the ROS package standard messages, or stdmsgs. For a list of available message types in standard messages, see that site. There are a lot. We're going to just use int32 here, but there are a whole slew of them. Creating a simple publisher node. The code accompanying the text has a simple publisher node in the Rico topics package. Remember, I prepended my name to the beginning of all of the packages from the text. You should use catkin create package to create a parallel package in your own code repository as follows. So catkin create package, the package name, my topics, it could be your first name then topics, and then here are the dependencies that we'll be using in this package. So this is the package associated with this chapter, and if we bop over to the virtual machine here, then what we've got is in our workspace. We have to have a ROS workspace, of course. See what's here. Let's cd down into source, and the robotics book code, hopefully you've got it there in yours, and example is the repository I made showing you how to set up your own GitHub repository. So let's put it in there. So in the robotics code repository, I'll show you quickly. If we go down to Rico topics and then source, we can see there's a topic subscriber.py in there. And we're going to, topic publisher.py. We're going to create our own in this lecture, topic publisher.py. But if you wanted to take a look at what's in there, you could open it up in a text editor like subl topic publisher.py, and it would show you what's in there from the repository, the book repository. We're going to make our own version of this, or you're going to make your own version of this in this lecture. So we'll navigate up to the workspace source, and we'll go now into what will be your repository. So into example, and we made that my first package last time, but now we're going to create a new package which we're going to call my topics. Okay, so in order to do that, we're going to use this catkin create package command here. If I can properly get it copied. There we go. Okay, so I have to take out this line break. For some reason on Ubuntu Firefox it copies it like this. So catkin create package my topics, the name of the new package, and then the dependencies, ROS-PY, standard messages, message runtime, message generation. We'll talk about these later. We've seen ROS-PY and standard messages now. The other two will come in later. So now we've created this package. Now I see that my topics is here. So if I cd into my topics, I've got a package.xml file. I've got a source directory. So if I cd into source, well, before we do that, I'm actually going to go back up, because the next thing I say is we'll need the dependencies listed above. So create a new Python file in the my topics source directory. So if nothing's in source right now, so I can create a new file by using the touch command. Okay, so my topics source, and then I'll call it topic publisher.py. And now I need to open this empty topic publisher.py in a text editor. So I'll do subl. I'll just use the previous command because it's got the directory already there. And I'll just use subl to open it in Sublime Text. And there's my empty Python file. So I've got the one that the robotics book code comes with, and then I've got the one that I'm making into a new package right now, or into a new node that will run for my package. So we'll want to enter here the same code that appears in the sample topic publisher.py file from the robotics book code Rico topic source file. So that's this one here. And for the purposes of the lecture, I'm just going to copy and paste it, but I recommend that you actually go through line by line and type it so that you make sure that you understand all of it. So I'll save that. Since this is the first ROS-PY node we've written, it's worth considering it in detail. Okay, so the first line is called a shebang. So let's see if I can make this bigger. Yeah. So this first line is called a shebang, and it tells the operating system how to handle this file when we give it to the operating system. So we want it to be executable. Okay. So this shebang here indicates that this file, this .py file, is an executable file, and specifically which interpreter we're going to use. For us, it's going to be Python. Okay, and that's where Python is located on our systems, on our Ubuntu systems. So one more step is actually required to make your new file executable. So we need it to be executable for it to be a ROS-PY node, or a Python a ROS node when we finally ROS run it. So in order to do that, we need to use this chmod command in Ubuntu bash, which modifies the permissions of the file to allow it to be executed by the user. So u+x, and then the file that we just made. So my topic source topic publisher.py. So now we've allowed it to be executable. And if we take a look now, we're going to take a look at this code a little bit deeper. I wanted to kind of take it part by part here. So what comes after the shebang is that we import our Python packages. So we'll import the ROS-PY package, and then we'll import some of the standard messages package. Specifically, we're just going to import int32, which is what we're going to use as a counter. Okay. These packages show up in the package.xml file as dependencies, and that's because we used cat can create package. We don't have to go in and manually put them in there as dependencies, but we could if we had forgotten about adding, say, standard messages to our package as we created it. We could go into the package.xml file and add the standard messages as a dependency. So the first thing we're going to do then, after we're done bringing in our packages, is we've sort of two main sections here of this code. So the first is that we set up. So first we're going to initialize a node, we'll register a topic, and then we'll set a rate. So the first command is to initialize the node. We'll use the command init.node, so ROS_pi method init node. To initialize a node, we give it a string, which is the default name of the node. So if it gets called by ROS run or ROS launch, this is the default name that it'll have. Of course, we can give any instance of this node a different name, but this is the default one if it's not given. The name's not given. And then we will initialize the node. Then we're going to publish a topic. So essentially, we're going to register a topic with ROS_core using the ROS_pi.publisher method. And this creates an object that we'll assign to the pub variable. Okay, and we give this method a string, which is the topic name. We'll call it counter. The topic type, which we've imported from the standard messages, is int32, so it's going to be an integer. And the queue size. Now, queue size, there's a lot to it. I give a link to some documentation here, and it's essentially how much of a buffer we keep around for this topic, how many messages we keep around. There's a chance that you can have drops in communication among your nodes, so it's good to the general recommendation is to have your queue size be greater than you think it needs to be. However, you don't want it to be too big, or you can run into some memory or lag issues. So there's a pretty good article on how to choose that, and it also depends on the rate that you're going to choose, which is the next thing we're doing here. In line 14, we've got this ROS_pi.rate method, and 2 is the adaptive rate of the loop to come in Hertz. So we're setting the rate that we would like the loop that we're going to start in a moment to run at in Hertz. So we give it 2 for 2 Hertz. We save that new rate object created by this command, by this method, ROS_pi.rate, to the rate variable. And then when we go into our loop, we're going to use this rate object. So we'll see how that happens in just a moment. So we go down a little bit more. So we've got a while loop now. We initialize a count variable to 0, and we then loop through while, and this loop will continue while ROS_pi.isShutdown is not true. So you can shut it down by Control-C as usual. So while this node is going, we haven't seen a shutdown command, we will continue this loop. Okay. So what we first do is we publish the count, and we do that by calling the publish method on the pub variable, which is storing a publisher object, ROS_pi publisher object, and it has all the information. It has counter in there. It knows what the topic name is. It knows what the topic type is, and it knows what the queue size is. So when you tell it to publish, it knows all that information. So pub.publish, and then you give it the count, which is an integer that we just saved. So 0 is the first one. Then we increment the count, so that integer will be saved and added 1 will be added to it and saved as count again. And then we're going to now use this rate object that we created. So we said that we want to be at 2 Hertz, and so we do rate.sleep. It knows that you want to be at 2 Hertz because when you initialized the rate variable, you gave it this rate object at 2 Hertz. So what it tries to do is adaptively do a wait here in the loop so that it gets called twice a second in this case, so every 2 Hertz. This is really nice. It's actually trying to, so it doesn't know what else you're going to be doing in the node beforehand, but it will sleep different lengths of time depending on how long the last execution took. So it's adaptive to your loop. So it's really nice for timing. It's pretty good at maintaining a rate. And we'll actually take a look at that a little later on in this lecture. So that's our Python code. This is our .py file, our topic publisher node, okay? And now that we've got this node written, and we've changed it so that it's executable, we can run and verify it. So first we need to do a cat can make on our entire workspace to make it available. So, well, that's to build it, I should say. So let's cd up to the workspace root. Oh, that went one too much. So there's my workspace. I can do cat can make. Okay, great. So we have now cat can made, cat can maked. And now we're ready to do to source our workspace so that it's available to our ROS commands. So source devel as usual, setup.bash. So now it's available. And let's open a new terminal and start a ROS core service. So new terminal here. Always got to have a ROS core running before we start any other nodes. So there we go. Now we can run the my topics topic.publisher node. So let's go back here. It doesn't, yeah. So let's go back to where we sourced our workspace, and we'll do ROS run. And then my topics should be tab available. So it should tab suggest my topics as a possible package to draw from. And then we're going to fire up a topic publisher node. And we don't need to give it a unique name. That's an option we can do at this point. But since we're only going to run one of them, we can just give it the default name. And it is running, although it doesn't show anything. It's running. It's just in the loop essentially right now. So our node is running. Let's check the current topics to see if counter is being advertised. So let's open up a new tab and let's do ROS topic, which gives us some tools for checking out what's going on in the topic publishing world. So ROS topic list, and this will list out the topics that are currently being published, being advertised. Counter is there, it's the first one listed. The other two are always there, don't worry about them, but the fact that counter is there is what we were expecting and hoping, so we can ignore the other topics. Great. Now, a couple other nice commands we can use are ROS topic echo, and then the topic name, so counter. Now I put -n3, which will give you only 3 counts, but I will let this one run. It'll go on indefinitely, continue to show what is being published to the counter topic. Now, if I hit Control-C, we'll get out of that. And there's a similar, there's another command in ROS topic that I wanted to mention, which is ROS topic Hertz counter. So ROS topic Hertz on counter. So ROS topic Hertz is going to print out the average rate that this topic is being published to. So we're seeing it's right at 2 Hertz. It does have a little bit of variation here, and it's adaptively trying to get better and better. So we see the max, standard deviation, and this sort of gives us some data on how we're doing in terms of our loop rate set by rospy.rate. So, and implemented using rospy.sleep. So that's our simple publisher node. It's pretty straightforward, but we were able to sort of create it from scratch in our own package, and as we go forward, we're going to use that same method of creating our side-by-side package with the textbook package, so that you can actually go through all the mechanics of creating it yourself. So that is that.